Hello everyone, welcome back to Kinetic Course. So in previous video we have discussed about basics of AI agents and we also built a small project regarding to it. So in this video we are going to discuss about agentic RAG. So without wasting any time, let's begin. So in previous video we have a multiplier time and date calculator and prime number. I mean it identifies the prime number and counts the number of words, right? So now let's add a superpower to it. So instead of answering only from the knowledge base, we'll add an external knowledge base to it so that it can search over it. By this end of video, you should build your complete agentic rack pipeline. So for our basic AI agent, let's give access to our documents. So let's talk about this. So we have discussed up to this part, right? AI agent decides to call the, I mean, it decides to call the which tool, right? So let's add a new tool called retriever tool. And inside that retrieval tool, here is our whole rack pipeline. That's it. There is nothing complex about agentic RAG. Just like tools like calculator, time, the retriever is a tool for it. We'll create a function called retriever and we'll insert it. This is what an agentic RAG means. That's it, guys. Nothing complex. So let's master it. So first of all, we need to import our document loader because we need to load our document, right? So that is the first step of RAG. We all know it. Langchain underscore. So here is our text loader, which loads the particular document. Now we need to chunk the document. So from Langchain text splitters import recursive character text splitter, which is used for chunking. Now we need to import the embeddings model. Hugging Face. Oh, sorry. Langchain underscore Hugging Face. Import Hugging Face embeddings. Got it? So we'll create embeddings through this model so that it's a free model and we have not to keep charges on APIs. So let's load our LLM first. I think it's done. Okay. So we need data. So we need to load the data first of all. So loader equals to text to loader. Inside parentheses, we need to keep our file name. Since we don't have any file, I'll create a file called data.text. So this is the data. So we have used this in our previous sessions also, right? So yeah, data.text and our documents equals to loader dot load, and we all know this stuff. So our next process is chunking. So splitter equals to recursive character text splitter. So here we need to give our chunk size and chunk overlap. So I'll give it 100. Oh, sorry, 100. And our chunk overlap equals to some 20. Now we have created the chunking model now. So our chunks equals to splitter oh, dot split documents. And we need to give our variable documents. Fine. And now we need to create our embeddings model. So my embeddings equals to our library Hugging Face embeddings parenthesis and our model name will be BAI dash slash BG E dash small dash EN dash V 1.5. So this is our embeddings model. And next, we need to create our vector database. So let's import our vector database underscore current import yeah import our vector database quadrant vector store. So now also we need to import a client, right? From yeah, I think LangChain is not essential for this. You can simply import like quadrant client, import our client. So it's done. So yeah, here. So for now we'll use our in-memory database. So our RAM will be used for it. Client equals to quadrant client memory, which uses our random access memory. I mean, all the embeddings were stored here, right? So now we need to create a vector store. So my variable vector store equals to our quadrant vector store dot from documents parenthesis. First of all, we need to give our documents to this. So our documents equals to our chunks, right? And we need to give our embeddings also. So our embedding equals to our variable embeddings, right? So we need to give our vector client. So I'll make this something like clients so that the variables will be different. Mm, clients. So which is our variable, right? So for this entire vector database, we need to give a collection name. So my collection name, which I'll give is oh, sorry, agentic dash rack. I think it's fine. We have discussed about this in our previous lecture. So if you haven't watched it, so kindly have a look. So this single method creates the vector database. Stores are embedding in that, right? We are giving, I mean, we are giving our chunks and our embedding model to, hey, you create embeddings for these chunks and store it in your vector database. This single method can do that. Got it? So now we need to create the retriever. So my variable retriever equals to vector store dot as retriever. Okay. Search quarks is equals to, here we'll give k equals to, no, I think so. K is to 3. So colon, right? So we all know what is k equals to 3. Suppose we got, mm, yeah, suppose we got this document as a response. I mean, suppose this document is an answer. Here k equals to 3 means 1, 2, 3. Sorry, 1, 2, 3. It takes its preceding document. I mean, it uses its preceding data and succeeding data for a better answer. So as you see in ChatGPT, when you ask an answer, it gives more information according to it, right? So why? Because of this K top K retrieval, because of this method. So if you give, I mean, as long as you keep on increasing this value K, you'll get more information, but it will be complex. Also, there will be um, useless data for you. So if you give balanced, you can get good result as well as a good content. Now let's give a query. Query equals to, I mean, let's test it just. Retriever dot invoke. Let me give my query, which is tell about drag, and let me remove this print statement. I mean, this loop, and I'll print. So let's call our retriever. So for I in our query, print I dot page content. So in our query, what is stored? Sorry, I'll give. something like answer, because this is the query, and inside the retriever, I mean the retriever searches in the embeddings for this particular query, and the matched, I mean the most similar documents will be in the answer variable. Got it? So let me print our answer I underscore page content. Good. So we have got an error, guys. So according to my LangChain version, I'll import from quadrant client, import quadrant client dot models. Yeah. mm, yeah. Vector parents comma distance. Don't worry, I'll explain about this. Also, we have discussed this about, I mean, we have discussed this in our previous video. So if you don't know it, kindly also have a look. So I'll also explain it here, no problem. Mm, yeah, let me remove this completely. First of all, we need to create the collection. So for that, clients dot create collection. So here we have to create the collection name. So our collection name equals to Agentic rag, right? So our vector configuration, which means vector config equals vector params, which means vector parameters of where our size is 384, and our distance equals to distance dot cosine. So this means the nearest vector. So this function, this line is very important, guys. Without this line, we cannot identify the nearest vectors. Got it? Distance equals to distance dot cosine means it measures the nearest vectors, nearest embeddings, right? So size equals to 384 means vector size is 384. So this is vector configuration. We are configuring the vector and our collection name. So here entirely we are creating a collection manually. Got it? So now let me create my vector store equals current vector store parenthesis no from documents, right? Here we not need to insert any from documents. We can directly write here. We need to give the client, which is equals to our clients, right? Also we need to give our collection name. So our collection name equals to Agentic rag, which we have created here itself, right? Also we need to give our embedding, which is equals to our embeddings. Got it? So we have given everything. Now we need to give our chunks, right? So outside of this, we need to give the chunks externally. Vector store dot add documents. Inside that, we need to write our document chunks. Got it? So in this way, we can create our quadrant vector database. So now let me change this to here just normally, right? So okay, let's run this. So we have got a response. Um, so what's our query? Sorry, I forgot that. Tell about rack. Okay. Retrieval augmented generation rack combines retrieval with generation. Okay, first we have got this, which is very good. Notice we didn't send our response into an LLM, right? So let's do one thing. Let's write a function which contains of this context, which is given by retriever. So yeah, okay. Mm, okay, I'll simply write it here. So def rack. Yeah, simply I'll keep as I think. Yeah, it's good, no problem. So the input which we give is a string data structure. So query, which is a string data structure. Also, it should return string. So I'll give a description here. Mm, search the knowledge base and retrieve the relevant information. Fine. So content, I'll create a variable called content, which is equals to retriever dot invoke our particular queries, right? So it should return that particular content. Mm, okay, I think dot join for doc in our content doc dot page content. So now this is not a, I mean, this is no more a normal function. It's an AI tool, right? So we have given the description here. Search the knowledge base and retrieve the relevant information. The content equals to retriever dot invoke queries, which invokes the user input and returns the page content here for doc in content. Got it? So let's do one thing. So I'll remove this. Yeah, I think it's not useful. Good. So now tell me about about Python. Python. So let me clear the terminal. Oh, really sorry guys. I forgot to give this in our toolbox. So yeah, this is our function name, right? So where is our toolbox? Okay, sorry. Yeah. So let's paste it here. Good. So let's give another try. Sorry guys. Also add your print statement here. Yeah. So we have got a big output. So our content is tell me about Python. So yeah, Python is widely used for artificial intelligence development. Got it. So this is our response, which means it's working well. So now let me ask about, let's do a simple calculation. Multiply into anything it might be. So we have got an output. So our question is multiply 1478 into 9632. Okay. So the multiplication is 14236096. So now here is the multiplication solution. Now let's ask what is the time now? So the time is 2. Yeah, and today is 2nd August, Friendship Day. So that's it for today, guys. In this video, we have built a basic agentic rack pipeline. So next video, we are going to discuss about memory. We are going to add memory for this. So see you in the next lecture. Jai Hind.